Creating and altering tables. Tables, as we all know, they are the physical structures we use to store data. Whether we store data permanently or temporarily, we need to understand how to build these tables. So we're going to start this nugget off here with an objectives overview, talk about what Microsoft wants us to know as far as this topic goes. We'll cover things such as temporary tables versus table variables. We'll look at data versioning management and why you would want to store multiple versions of data and how you would do it. And then we'll also look at alternatives to triggers. Triggers are great when you want to respond to actions that occur on your data. Popular uses like auditing or change tracking. But the thing with triggers is they can cause a lot of headaches from a performance standpoint, from a management standpoint, and even from a development standpoint. They can cause a lot of headaches. So we'll look at some alternatives to trigger usage. Then we'll jump into the virtual Nugget Lab and we will create the entire Nugget Demo DB schema. So I've got a nice script ready to go that will create our tables, alter our tables, and if we ever need to recreate the structure, it'll blow them away and recreate them. So we'll get familiar here with the create table statement, altering tables, even working with computed columns in tables. And then we will load that Nugget Demo DB up with data. So I've got some raw source files that I received from the awesome Nugget team. We're going to take those source files and load up our tables. I'll show you a few ways to do it. One way to do it is using bulk insert along with a format file, a BCP format file, and that's going to be good for simple formats. But complex formats where you have different formats, maybe you have some data that's quoted, other data that isn't all in the same file, then format files in BCP and bulk insert get a little bit tricky. So this is where we're going to bust out our SSIS skills, and I've created an SSIS package that we're going to use that does it all. Creates our Nugget Demo DB structure, loads it with data, and gets us ready to go throughout the rest of this course. So that'll be a fun one. We'll get our database created, we'll get it loaded, and then at the end here we'll work with temporary tables and table variables to get familiar with how to create these structures and load them up with data and then work with the data inside of them. Let's start with a whiteboard and go over some of the main objectives associated with this nugget. So one of the major objectives for this nugget is understanding the difference between a table variable and a temporary table, and then obviously creating both of these, which we'll do when we get into the Nugget Lab. So both of these serve the same purpose: temporary data storage. A lot of the times when you're in a stored procedure, you need to pull data from many different places. It's easy to stage it all in a temporary object that you can then do processing on to shape your final results. But there is one big question that always hits every SQL developer's mind when it comes time to temporarily store data. What do I use? Table variable, temporary table. And the answer to that isn't as simple as you would like it to be. It depends. It depends on your situation and what you're doing. And it helps here to list some of the positives and negatives associated with both of these, which will help you come up with the right solution for your situation. Generally, you're going to want to use table variables on small data sets. The reason that you'll want to do this is because of the next item here on the list, and that is we cannot create non-clustered indexes. You can only create implicit indexes, meaning whenever you pop a primary key on or a unique constraint, you'll get an index with it. So you're not going to be able to selectively index what you want to using table variables. So that's why they're good for small data sets. If you do have large data sets, then a temporary table is going to be your answer, simply because we can put non-unique indexes at will on any of the columns inside of them. Another item that can greatly affect performance is deleting versus truncating. Table variables do not support truncation. You can only delete, where temporary tables do support truncation. So if you're moving a lot of data in and out of your temporary objects, then again, you'll probably want to use temporary tables because you can just truncate what's ever in there rather than running delete statements. Another big one for performance, and this is on the table variable side, is that stored procedures are not recompiled. And that's a big deal because with temporary tables, they are going to get recompiled often because the structure is unknown at the time that the stored procedure executes, so it needs to come up with its plans dynamically when it's executed. So that can be a big performance hit. And then finally here, no transaction support on table variables, where temporary tables do support transactions. So this can be a performance increase if you don't care about transactions. But if you do need transactions, then you'll want to use temporary tables. So all this boils down to one thing, and this is a great rule to live by: use table variables wherever possible, whenever possible. Make that your default go-to temporary storage object. And if you have any of these requirements, then use temporary tables. Oh, and an interesting side note here, in SQL Server 2014, this limitation goes away, which means we can create non-unique indexes on table variables, which even cuts down into our small data set side of table variables. So we'll have even less reasons to use temporary tables in the next version of SQL Server. Another objective for this nugget is data versioning management. Data versioning is anytime a record changes, say that we wanted to take a snapshot of that record and store it somewhere. That way we have history and we can see how data evolved over time. Now, if you don't have these requirements, then you're always going to have the current state of the record inside of a table. So data versioning management you'll want to use for that data that you want to see historical views on, or you want to do change tracking on for auditing purposes and such. But it just allows us, again, to see how data evolved over time. And a lot of the times this is accomplished using archive tables. And a lot of times that's accomplished by just mirroring the schema on your production table. And then anytime a record changes, you push that record over to your archive table, date stamp it, and then you always have the current version in your main production table. And a lot of the times for auditing purposes as well, you'll store before and after snapshots. That way you have a trail of everything that happened to that data. So how do we accomplish this in SQL Server? Well, one way is triggers, but as you'll see, not the best way. It's just triggers have been around for a while. They're easy to work with, but again, you'll see some of the headaches that we'll go over here shortly. CDC change data capture is a nice feature that is better than triggers because it actually reads the logs, so it has no impact on performance, and it's a great way to do change data capture. But my favorite way here is the output clause. The output clause is great because we can attach it to the end of our insert, update, and delete statements to capture what happened to the schema that those statements are ran against, and gives us access to the same insert and deleted tables that triggers use for their data storage. And I'll give you a good example of the output clause when we get into the virtual Nugget Lab, because we're going to use it extensively in our data loading process. The last thing we need to cover here is triggers. We'll look at some common trigger applications, some of the problems that triggers cause, and then some alternatives. So some popular applications. In fact, one of the most popular applications you'll see out there is enforcing complex constraints or business rules. So when data hits a table, you need to run your logic. If it all passes, then you'll accept it. Otherwise, you'll reject it. And this, believe it or not, is where people get in trouble with performance. Because triggers themselves really aren't that bad on performance. It's all the logic people stuff into them that just absolutely crushes performance. Another popular use, as we saw it on here, audit trails and data versioning. Again, when data hits a table, the trigger, inside of that trigger, we have access to what the new data looks like. We have access to the old data. So it's an easy way to take before and after snapshots. It's also an easy way to do auditing because we know who touched it. We have access to functions that can get the user that touched it and even what columns or what data they updated inside of that table. So we can track all that information and put it inside of an audit table. Notifications, another one, and I'm guilty of this. In fact, I think I did this in a previous SQL series where we send emails from triggers. And it's okay to do on small tables that do not have a lot of activity, but you can really slow processes down if you're on a busy table. So avoid sending emails if you can. A better alternative here is use the output clause, put it inside of a different table, a queue, and then process off of that queue. Updating related data, another popular one. Good for firing sequences and referential integrity. Anytime data hits this table, if you need to send updates to other tables, it's a popular application. So what are some of the common problems you see out there with triggers? As I like to say, mo triggers, mo problems. The first one here, visibility. This is a big one. And it's big because triggers are invisible to client applications. Let's face it, they really are. Applications are either going to use views or stored procedures. They have no idea that there's triggers on a table. And this can cause a big problem. I've dealt with applications before that send common error messages, referential integrity violated or some kind of data violation comes back, and you have no stinking clue where that error is getting generated from. You've gone through all the stored procedures, you've gone through everything that application touched, and it's still generating the errors. Well, and it's always the last thing you look at too. You're like, oh, there's a trigger on that table. Let's disable it and see if the application works, and it does. But then you've got other issues. You've got data issues, and you see where I'm going. It turns into this big stinking mess. So visibility is a big one because triggers just feel like these hidden ninjas inside of a database, and a lot of the times they can cause problems. Performance, we've talked about here. Performance, again, the more triggers you have in a table especially, but the more complex logic you have in a trigger even more so, are going to cause performance issues. Testing, there's just no good way to test a trigger. You got to have patience, and you've got to write a lot of a lot of insert statements or update statements. You've got to put a lot of data in that table to test it out and to make sure that there's nothing you didn't miss. Maintenance and migrating, always a headache when you have triggers on a table. Batch processing, and then because triggers are switchable, you can turn them on and off. You can get into trouble because if you turn a trigger off for a data load and forget to turn it back on, and now all of a sudden you're getting invalid data inside of here, you're going to have to go extra steps to clean out your data. So the fact that they're switchable can actually cause quite the headache if you're not careful about what you do. Have I bashed triggers enough? I think I have. And I like triggers. Don't get me wrong. I've built many in my day. I just think after being bitten by them so many times, you have to be smart with them. You have to remember that they're a part of your process, and you have to keep them simple. And you should also make sure that there's not an alternative, because looking at the alternatives down here, a lot of these things we can accomplish using check constraints. We can do our complex business rules and logic and check constraints. We can use the output clause for audit trails and data versioning, and then we can use stored procedures really for everything else. Make sure that you can accomplish it using these alternatives before going and putting a trigger on that next table. All right, I think it's about time we head into the Virtual Nugget Lab and see some demonstrations, get some real-world experience here working with tables, both permanent and temporary. Welcome to the Virtual Nugget Lab. So I have SQL Server Management Studio pre-launch. Let's bring it up. And I wanted to give you another bird's eye view on our schema. And also, we have a new table in here. Now, I added this new table because we have a many-to-many relationship between categories and courses. I realized this once I got the raw data from the Nugget team. And if you remember in the first Nugget, I did mention that we were going to try to do a recursive CTE against categories. Well, I also realized that we already did that in 70-461 with managers to employees. We created that recursive CTE. So rather than duplicate content, I figured we would go the way that we should go here, and that is represent a many-to-many relationship with a table in between, an intermediate table. That way we have a one-to-many between course and course category and a one-to-many between category and courses. That way we can still represent categories across many courses and courses across many categories. So with that said, let's bring up Solution Explorer, pin it down. You can see I added a new project into our solution, O2, and we're going to open up our first script here, create_tables.sql. Now this is a script that is going to recreate our entire database structure. So this is and scripting out your structure is a great thing to do. It makes it easy to migrate it to a development server, a test server, or whatnot. But there's a really easy way to do this. And you know, you can create your tables by hand. Right-click, new table, create them graphically to save on typing, and then you can script out your tables either singly, one by one. Singly, is that a word? One by one, by just right-clicking, script it. You can script the create, script the drop and create. You can even select your DML statements against it, which is really nice. But you can do it that way if you want to do a single table, or you can just right-click on the database, head into tasks, generate scripts, and you can walk through this wizard, pick your objects. Let's say we wanted to script all of our tables. Here we could do this. You can save it to the file, clipboard, new query window. But see this little advanced button? This is where all the goodies are. So click on this advanced button, and this is where you can choose your scripting options. So if you want to do a script drop and create, if you want to have the if statements generated and do a check for object existence, and also if you want to script data, which is a question I get all the time because it's a really useful thing to do, and it's exactly what I did here for the tables that I did not get data from nuggets. Learner nugget activity, learner nugget info. I'll show you how I generated that data. But you just drop down types of data to script and choose data only. Now you can script the data, which will just script out a bunch of insert statements. So not only can you script your schema, you can also script the data if you have some in there. And again, makes it easier to port if you're not doing a database backup or whatnot. So just wanted to show you how to do that. Now let's walk through our script. So the first thing we're doing here is just checking if they exist. And so we're first checking if all of our keys exist. Here you notice these are all FKs, foreign keys. So if all of our keys exist, it's going to do an alter table, name of the table, and drop them. If they don't exist, then it'll ignore all these. But it's going to do that for all of our constraints, whether they're foreign keys, defaults, and that's pretty much all we have here right off the bat here. Then we're also going to do if exists on the tables. If they do exist, we're going to drop all the tables. So just by doing this right here, in fact, here, let's do our constraints too. We need to do them all here because if we don't drop our constraints, we won't be able to drop our tables with foreign keys references on them. All right, so let's highlight all that, hit execute. There we go. Now if we sit over here and refresh our tables, we have nothing. We have an empty database once again. Now let's scroll down a little bit further. The next thing we do is recreate our tables. So here we have our course table, which has an identity on it. So this will be an auto number. We're putting our primary key, a clustered primary key on our course ID. We have our trainer table, nugget table, category table, course category table, learner nugget activity, and learner nugget info. Then we're going to create a couple of functions. The only functions we're going to create right now is get course nuggets and get course duration, because on our course table, if I scroll up a little bit here, you will notice that the last two columns, we have total nuggets and total duration. So we want these to be computed columns. Since we'll have that data, we can have them be computed. And computed columns, by the way, can hurt select. They can hurt select statements, especially if you have a busy table, but you can persist them. Persisting means it'll store it on disk and allow you to index them, so you can get rid of that performance consideration. Just something I wanted to mention there. But if we back to where we were here, we're going to drop these functions as they exist. Then we're going to create them. And these functions just go into the nugget table to count all the nuggets, and they go into the duration table to get the duration. And we'll talk about what exactly they do here once we get our data loaded. Then we're going to drop the existing columns and re-add them as computed columns tied to those UDFs. And the reason we need to do this is because we're referencing data out of another table. Right? We want to count data that's in the nuggets table from the course table. So this is why we need to use the user-defined function tied to its formula as a computed column. Then the last thing we do here is put all of our constraints back on. We put our defaults on, and we end it by putting all of our foreign keys on, and that's it. So we could execute this all day long, and it's just going to keep dropping and recreating, dropping and recreating. Now if I hit refresh here, there it is. It's back. So it's a great script to recreate the schema in our database. Granted, we have no data in it, but that's next. Now let me show you the source data I got from Nuggets that we're going to pull in, transform, and make it our own. And the one big thing we're going to do here is we want to use our own IDs. We're not going to use the IDs that Nuggets supplied. We're going to use our own IDs, our own auto numbers across all of our tables. So this is going to get interesting. Let's open up the directory here, go into our local C drive, into our Nugget Lab files directory. And I've got two data directories in here. One is all of our raw SQL Server files, so our MDFs and LDFs, our data files. And then Nugget Demo DB data is our source data, our CSV data that we received from Nuggets. And so let me open up, say, instructors. Here's all the instructors at Nuggets, and this is what the file looks like. We have a header here. There is a line break, you just don't see it, and then we have all the instructor data. So ID, first name, last name, certifications, and area of expertise. If we open up series, which are now called courses, you can see we have that same data, ID, title, subtitle, category, and all that data in there. There's like 260 or 250 plus courses in there. We have videos. There are 5,000 nuggets inside of this file. And then we have series category. This is our intermediate table that ties series to categories. And then we also have a categories table, and then what instructors are tied to what courses. All right, so we've got some good data in here. I also created a couple of format files so I could show you how bulk insert works against this data. But ultimately, we're going to go to SSIS to do this. All right, so that's the raw data. So that's going to cover category, course category, nugget, and trainer. We still have learner nugget activity, and learner nugget info. Now, this data I generated myself, and how I did it was using Redgate's data generator. Redgate's, they're just an awesome company with a lot of good SQL tools out there, so definitely check them out. I just downloaded their trial for data generation. I generated 10,000 learners, 50,000 learner nugget info that attaches learners to nuggets and all the activity they do on them, and then 1 million nugget activity records. So anytime they do anything in that video player, we want to track. From there, I used what I showed you earlier and generated the script, only I chose data only, and that just generated all the insert statements for all the data inside of here. So we've got all that data sitting inside of all those insert statements sitting inside of this static SQL script, which we will reference from our SSIS package. All right, so let's work on our source data first here, getting the data from those CSV files into our tables. So let's open up our load tables source script here. And the first thing I want to show you is the way that we're not going to do it, but I just wanted to show you for reference because it is a good way to do it if your formats are consistent and simple, and that is bulk insert with format files. This is a great way to work with temporary objects as well, because generally when you bring in data, you want to stage it and then work on the data from that staging area and port it into production. Well, this is a good example here by creating a temporary table, then loading that data from the CSV files into this temporary area, and then working on that data. Now for us, we're just going to create the temporary table, and this is a local temporary table because of the hashtag here. That just simply means that it's local to this connection. So if this connection were to disconnect, or if we were to close or kill this connection, then that table would get destroyed. But with that said, you should always explicitly drop your tables. It's safe and just a best practice there. So we create this temporary table that mirrors the schema of the CSV file. Then we're going to run a bulk insert specifying that table. specifying our CSV file, and then specifying our format file. Also with a first row of 2 because we have header, so we want to skip the first row. But if we look at this format file in the file system here, called trainer.fmt, you'll see it's pretty straightforward. And I actually generated this using BCP. You can use BCP pointed at a real table that you have, and it'll ask you what your delimiter for each column is and your lengths and all that. And it'll generate this, which is just simply SQL Server version, number of columns, and then it breaks out your schema definition for each column. So these are all SQL characters, and then the important ones here are going to be your length, your delimiter, your sequence, the name, and there's also the collation over there to the right. So this file is a little bit tricky because we have quoted identifiers in them. We have quotes surrounding string fields in case there's a comma. Since we have comma as our delimiter, it would break the delimitation. The format, the delimitation. It would break the format of our file and then cause import problems. All right, so let's close out of our format file here and let's just run this. So this will create our temporary table. It'll bulk insert into it from that CSV file. We'll grab everything out of it so we'll see it on screen. Then it'll drop that temporary table. And there is the results. Cool, right? So that's one way to do it. But I quickly realized I wasn't going to do it that way. That way we could do pure transact SQL, be a good showing of how to use temporary tables. But I quickly realized that this is a good real-world lesson. that when you work with files, that sometimes they're not all going to be the same. And that was a good example here because I believe it was our series, or maybe it was our videos files, but here actually it is our series. Some of them are quoted, but if there's no space, then if there's no space in the title, then it won't be quoted. And that causes problems with BCP and bulk insert, and that's where you can go down a very timely path, you know those paths that turn into time vacuums and all of a sudden 6 hours later you're still working on the same problem. Yeah, that's where I went with this. And then I said, you know what, Microsoft and everybody says just use SSIS because it's easier, so I ended up going with the SSIS route because it's easier, it's awesome, and there's not much you can't do inside of SSIS. So that's what I ended up doing, but I did want to show you this here for reference because it is a fantastic way to use temporary tables, and again, it's good for simple formats. So let me scroll down here. Here's what we're going to do. We're going to use SQL Server Integration Services, but rather than create temporary tables, we're going to create real tables, just staging tables. So we'll still call it trainer_raw. It'll just be a real table rather than a temporary table, and it will only exist for the length of our import. So we're just going to stage it into permanent tables, push it into our production tables, then drop all of our staging tables. It's a lot easier doing it that way anyway. Now, before we look at the rest of this process, let's just head over to SSIS really quick. Let me show you what we got. So this is our ETL package that's going to prepare the environment, stage our source data, load the production data, and then drop all of our staging tables. And this package does it all. This package will first run our create production tables, which is going to run our create table script that we were just looking at, this one. So this is what that linked to. It's going to run the script, which is going to drop and then recreate all of our tables. Then it's going to run a create staging tables script. This is just hard-coded. This is going to create all of our staging tables. All right, pretty much the exact same thing that you just looked at that bulk insert table and our temporary table. We're doing the same thing, but these are all going to be permanent tables. So they're the staging tables that model our CSV structures. All right, so that's all that's going to do. Prepare environment, prepare production environment, prepare staging environment. Then we're going to stage all the source data. We've got a bunch of data flows in here. This is going to take data from the CSV files. Each one of these just has a flat file source, which links to the flat file. So here, this would be the link to the CSV file, and it's going to load it into that staging table. So it's going to do that for every CSV file that we got from the Nugget team. Then we're going to load up our production tables, and this is what links to the SQL script we were just looking at right here, which is what we're going to go over. So that's the point where we're at. It's going to load all the source data. Then it's going to load all that static data, run all those millions of insert statements, and then it's going to drop everything. So it's actually pretty straightforward. There's not a lot going on here. But let's head back to our script, and this is where really the bulk of it is. So if we want to load trainers, rather than doing the bulk insert methodology you saw above, we're going to have that staging table created and have all the CSV data in it. Now we need to take that CSV data in our staging table and move it into our training production table, ensuring that we get new IDs. Now, because we want to generate new IDs, it makes things a little bit tricky because we need to maintain the linkages across all of our data. When it comes time to import courses, we're still going to need that source ID to figure out what course belongs with what, and we can tie the right new ID to the right data that's coming out of the CSV file. So what this means, and this is a great usage again for temporary objects, what this means is we're going to need a temporary area to store this data. So we're going to create a variable called trainer temp that's going to store the new ID that gets generated from our merge statement here, which we'll go over shortly, and then also going to contain the source ID that's sitting in that CSV files. That way we can maintain the linkage. When it comes time to import the course, we can do a lookup in this table to figure out what goes where. We can get the new trainer ID and associated with the course rather than the source ID. So temporary area is great for this because it means that we do not need to create a source ID column inside of our production tables. All right, so that's why we're doing this. So let's go over this a little bit here. So this merge statement is pretty awesome. Basically what we're doing is we're saying the trainer is going to be our target, and then our source is going to be a query that grabs all the data out of our trainer raw table, right? That gets created our staging table that we just looked at in our SSIS package. Then here we're just saying on 0 equals 1. This is just a way to say it doesn't match, so run this because it's not going to match and we don't have an expression for it. So this is a nice little trick in using merge. So essentially what we're doing is we're saying when it's not matched by the target, which it's not going to match because this data doesn't exist, we're importing it. We're going to run an insert against our trainer table. Let's expand this here and you'll see that we're going to insert into first name, last name, certs, and expertise. That's all the data we have out of our source files, which means photos will be null and trainer ID will be automatically generated. Then we're going to specify the values for that insert statement is going to be the first name, last name, certs, and area of expertise from our raw data. So this is what it looks like at the end. Then we're going to use this handy dandy output statement. This is awesome. This is really awesome. To take the generated trainer ID, the auto-generated trainer ID, and the source ID and put it inside of our temporary table. So you wouldn't believe it. We just did a lot with a little merge statement and using some tricks in here, but that's just awesome. Now, that data is going to go into the trainers table along with the new ID and the source ID. That way we can reference it down the road here when we load anything that needs that information. Now, if we scroll down categories, we're going to do the same exact thing. It's pretty much the same code, just pointing to the category table. Then courses, we do the same thing. We need to store the course. We need to store the category. So that's pretty much all we need to store. Course, category, and trainer. Those are the three source IDs we need to track. Because when we load up our course category table, this is what's going to maintain the linkage between our courses and our categories. We're going to link to the course temporary variable, table variable, and we're going to link to the category table variable on the course ID of our raw file with the source. So again, that's all so we can maintain those linkages. And then we're going to pull out the new ID of the course in the category and store it in this table. So that'll give us the linkage on our side. And then same with nuggets. With nuggets, we need to load up, we need to know what course it's associated with. So we link its raw nugget data to its raw source ID, and that will allow us then to get the new course ID out of the temporary table and store that inside of our database. So that's it. That'll load everything up. The last thing I do here is just generate some random dates. We didn't get an uploaded date, for instance. So I randomly generate a completion date, and you'll notice that actually right up here, right here inside of our course, we randomly generate this completion date between a 10-year period from 9/1/2003 to 9/1/2013, and then I just generate an upload date that is make sure that it's before that completion date. So that should get us all of our data loaded from our raw files into these tables. Then after that, it'll also load up the static data. In fact, if we head back to our package here, it'll load the static data after that, and that's it. That should be everything. So let's do this. Let's run this entire package. I'm just going to hit run here in SQL Server Data Tools. It's going to recreate our production tables, create those staging tables, load up those CSV files into staging, then load all of our source data from the raw CSV files into these tables. And then the static one, because like I said, it's a million plus insert statements, is going to take a bit. All right, we're done. We made it. Not too bad. That took about 10 minutes to load up all the data. Let's flip back to SQL Server Management Studio. I wrote just a couple of queries here just to make sure that we have the data and what it looks like. So here's our trainer data all loaded from our CSV files. If we scroll down a little bit here, this is going to be our course data. And notice these are our computed columns over here that are running off functions. Now, we did do a transformation as well here. In the source data, we had minutes and seconds broken out. Now, what I did is converted minutes to seconds, added them together, and we're storing it all in one field called duration that just stores all the seconds. And then if we head back here to our create table script, if we look at our UDFs, you'll notice then when we're computing this column, we're just converting it to hours colon minutes. That's what convert passing in 108. And then we're just doing a sum on duration and doing a left 5. That way we cut off the seconds. And it's just going to give us hours and minutes. And that's what we have right here. Hours and minutes. Pretty cool, huh? And if we scroll down at the end here is each nugget broken out. We have our correct course IDs in here. Brand new nugget IDs. sequence. There's the duration there, and that's about it. So all of our data made it in. Now we've got plenty of data to work with throughout this course. Now the last thing I want to do is just show you a couple of cool uses here for working with table variables and temporary tables. So table variables are great, again, for storing small amounts of data, but also generating data. So here's a common use. Say that we were to create like a calendar style report, where even if you had no data, you still wanted the data to show up. Or a report that had similar requirements, where if you didn't have data for a specific date, you still wanted that date on there, just with no data associated with it. So a common use here is to generate a temporary or a table variable full of dates, and then do a left join to it. And that's exactly what I'm going to show you here. So this is a very simple, we declare a table with one column, one table variable here with the date time, and then we just have a start date, end date, current date, where you can hard code date. So if you wanted to put 1,000 years in here, you could do that. Or I got a little dynamic piece of code here that will get the first day of the current month and the last day of the current month, just using date add along with get date and convert to give us only the date part of it, not the time parts of it. And then we also have a current date, so we can loop through each date and insert it into the table, and that's all it is. And loops are great with table variables as well, by the way. Don't use cursors, use table variables. It's a lot easier to loop through them. So let me show you what this data looks like here. Let's just do a select everything from our date table variable. We'll highlight all of this. That'll create the variable, load it up with data, and then I'll put it to the screen here. There it is. Look at that. So there's every day listed for the current month, which is September. So there it is. Now, let's do something more real world here. We're going to insert just some courses for this month. And this whole thing is dynamic, by the way. So if you run this a year from now, it'll still work. You should get the same results because we're basing everything off the day. And so we're going to insert 5 courses for the day minus a few days, added a few days. So that should give us a couple of data points to work with. And then we're going to write a query that just left out or joins that dates table variable to our permanent course table based on the completion date of the course and the date inside of our table variable. And that should give us that calendar style report. So let's do this. Let's highlight the whole thing, hit execute, and here it is. So it created a table variable, loaded up with data, added 5 courses for this month in there, and then ran a query that left joined. And the result should be, if we don't have data, it's still going to output the day. But if we do, it'll also output the day and the data associated with it. Cool, right? There it is. There's all the data that we just inserted there. And that's how that works. So that's one good use for table variables. Let me show you something interesting for temporary tables here. Now, a lot of the times you'll use temporary tables inside of stored procedures as temporary data storage or table variables. But a common question you see asked out there is, how do I get the results of a stored procedure into a table or a temporary table for analysis? Well, that's what we're going to do here. First thing we're going to do is create a stored procedure, which does the exact same things our computed columns do. So if you didn't want to use computed columns for performance reasons, then we could use a stored procedure to gather these stats. And we just have an inner query here, which goes and does all the aggregations. And we have an outer query that joins to it to get all the metadata around the course. And the end result will be the course ID, title, completion date, total nuggets, and total duration all added up. So let's say we wanted to put the results of this stored procedure when we executed it into a temporary table so we could write queries against it. Well, that's what we're going to do here, create a stored procedure. Then we're going to create a temporary table called course stats, and just contains the exact schema that the return, the result set of this stored procedure will return. Then, again, one of the nice things we can do currently in 2012 with temporary tables is put an index on them so we can speed up our queries. So that's all we're doing here, is creating an index called course stats on completion date and total nuggets. And then here's the magic. Ready? Insert name of your table, exec, name of your stored procedure, and optionally any parameters you have, and that's it. That'll fill up your table with the results of your stored procedure. Pretty cool, huh? And simple to do. From there, we're going to write a query against that temporary table that's going to pull out all courses where the year is in 2012 and the nuggets are greater than 15. And then we'll drop the stored procedure. I'm not going to drop the temporary table yet. I'll show you why here shortly. But let's highlight all of this. Hit execute. And look at that. So, and remember, this is not real data because we had to generate our completion data on our own, just random completion dates. But in this data, we had 27 courses that were in 2012 and had nuggets, total nuggets in the course greater than 15. All right, so that's that. Let's scroll down here. Let me show you one more thing, and that is the double hashtag. So these are global temporary tables. Global temporary tables last as long as no connections reference them. So if you create a connection, you create a global temporary table, it's going to sit, if other people or other processes hit that global temporary table, it's going to sit there as long as it's either dropped or the last connection is destroyed. So it's like a local temporary table, only a local is tied only to your connection, and it's dropped when either it's explicitly destroyed or you disconnect. But good uses for global temporary tables are if you need to reference data, temporary data, across multiple stored procedures or functions or processes within your database, then it's a decent solution. Although there are probably better alternatives out there, but it's a decent solution because you have a nice centralized point that all of those processes can see. So this, other than that, it works the exact same way. So this is going to create a temporary table called sessions global temporary table, put some data into it, output that data, and there it is. So the last thing here is how to drop these. Now notice we didn't drop our local temporary table or a global temporary table. And one thing I wanted to point out here is if you go into system databases, go into tempdb, and expand temporary tables, you can see them in there. Check it out. So there is our core stats temporary table. If you want to drop multiple temporary tables, then you can just comma separate them after your drop, and that'll drop them both. I also want to point out that we could still access this sessions table if we went into another script here, or another connection, another query window. There it is. See that? So we're accessing it from another connection entirely. So that's the whole point behind global temporary tables. All right, let's drop both of these. And now if we refresh our temporary tables over here, core stats is gone. In this CBT nugget, we learned how to create and alter tables. We started off with an objectives overview. We covered the differences between table variables and temporary tables, when you should use one over the other. We talked about data versioning management and also alternatives to using triggers. We then jumped into the virtual nugget lab and got a lot of real-world demonstrations on how to create tables with Transact SQL, alter them, how to load data into those tables using both Transact SQL and bulk insert and SSIS as an ETL package. And then at the end here, we saw how to work with temporary objects, both table variables and temporary tables. I hope this has been informative for you, and I'd like to thank you for viewing.